Hey, today we're going to talk about how to solve this equation, right? This is a polynomial equation of degree 6. Okay, so this is the equation, z6 minus z4 plus 4z squared minus 4 equals to 0. Okay, so we are only given one of the roots, right? So one of the roots is 1 plus I. Okay, so first of all, right, so you observe that the coefficient of this equation, they are all real, right? So the roots will occur in conjugate pairs, right? So this 1 plus I, so I would know that the conjugate root would be 1 minus I, right? So at least I know that, okay, these two will be the roots of this equation. Okay, so what else do I notice, all right? So, well, let's test whether this is an even function, okay? So for instance, right, if it's even function, then f of negative z is equals to f of z. Okay, so let's see if that is true, right? Because if it's true, then this will be a helpful information. Okay, so f of negative z would be negative z to the power of 6 minus negative z to the power of 4 plus 4 times negative z power of 2 minus 4. Okay, so simplifying this is actually z to the power of 6 minus z to the power of 4 plus 4z squared minus 4. Right, so this is equals to f of z, right? So I'm letting f of z be this expression, right? z6 minus z4 plus 4z squared minus 4. Okay, so that's good, right? Because this is an even function. So what else can I infer after knowing that this is an even function? Okay, that means the roots will be the opposite, right? The negative of each other. So in other words, if 1 plus I is a root, then negative of 1 plus I will be another root. And 1 minus I is a root, so negative of 1 minus I is going to be another root, right? So altogether, I can conclude 4 roots, right? So just based on this information, okay? So from the first info, right, which is the root that is given, I can get a conjugate pair. And then after knowing that it is an even function, I can get another 2 roots based on the earlier 2 roots that we have obtained here. Okay, so let's write out the roots, right? This is negative 1 minus I, and this is negative 1 plus I. Okay, so now I can get a quadratic factor, right, of this thing. Okay, so I know that, okay, so this is made up of z minus 1 plus I times z minus 1 minus I times z minus negative 1 minus I. And then lastly, z minus negative 1 plus I. Okay, so let's try to simplify this a little bit more. All right, so this is the quadratic factor. So I'm going to expand it first before I do anything else. Okay, so this is z minus 1 minus I, z minus 1 plus I, z plus 1 plus I, and z plus 1 minus I. Okay, so let me try to expand this using my calculator. Okay, so after expanding this, I will get z4 plus 4. Okay, so how do I get the other quadratic factor, right? Because the whole thing, the whole polynomial is degree 6, so this is z4, so there's another quadratic factor. So I could do a long division, okay? So I guess I would do a long division. Okay, so this is z to the power of 6. Okay, so there's no z5, so I'll pretend that there's a 0 z to the power of 5. And then there's a 4, oh, this is a negative z4. Okay, so negative z to the power of 4. And there's no cube, so pretend that there's a 0 z cube plus 4z squared minus 4. Okay, so this is divided by z4 plus 0z cube plus 0z squared plus 0z plus 4. Okay, so that's a bit squeezy. Maybe I should rewrite that. Okay, so z to the power of 4 plus 0z to the power of 3 plus 0z squared plus 0z plus 4. Okay, so this would be a z squared. Okay, so that will give me a z6 followed by 0 z5 plus 0 z4 plus 0 z cube plus 4z squared. Okay, so if I subtract accordingly, I have a negative z to the power of 4. And this one would be 0. And this would be minus 4. Okay, so next I will multiply this by a negative 1. Okay, so then I will get negative z to the power of 4 minus 4. Okay, so that's good, right? So we should expect that the remainder is 0, right? Because this is supposed to be a factor, right, of the original function. Okay, so now I can conclude that the quadratic factor is x squared minus 1. Okay, so in other words, I can rewrite this as okay, there, all right? So solving this, right, I can say that z is equals to 1 or z equals to negative 1, right? So these are the remaining two roots, right? So altogether, there are 4 roots, okay? So z equals to 1, z equals to negative 1, z equals to 1 plus I, z equals to 1 minus I, z equals to negative 1 minus I, and lastly, z equals to negative 1 plus I, right? So 6 roots all together. Okay, so I hope you find this video helpful. I'll see you again in the next one.